Hi, I'm Mike Jones, Principal Electrical Design Engineer for Analog Devices, and today I'll be introducing a 16-channel transmit, 16-channel receive, direct LS and C band phased array radar and electronic warfare prototyping development system. It's been coined the Quad MxFE. Many phased array radars, electronic warfare systems, and satellite communication developments require multiple channels to either electronically steer radiation into a desired direction or to achieve system-level benefits otherwise unattainable with single-channel platforms. To achieve this, a great deal of effort has been placed on attaining efficient synchronization across these channels, as well as providing the wide instantaneous signal processing necessary to achieve their end goals for the application. This signal processing has, in large part, been historically done with the resources of power-hungry, large-sized FPGA, or otherwise with the aid of costly ASIC developments. However, now the integration of multiple digital signal processing blocks, wideband DACs and wideband ADCs within a monolithic chip is enabling the offload of power-hungry FPGA resources to allow for smaller footprint, lower power, increased channel count platforms which can sample at higher rates than previously achievable. Such an example of this is the newly released AD9081 or AD9082 from Analog Devices. These chips integrate 4 12 gigasample per second DACs, 4 4 gigasample per second A to Ds for the AD9081, or 2 6 gigasample per second ADCs for the AD9082. They also incorporate 8 fine and 4 coarse digital up converters and digital down converters, each with its own programmable, numerically controlled oscillator. It incorporates programmable finite impulse response filters, as well as multi-chip synchronization algorithms to allow the user to achieve a known deterministic phase for all channels when powering the system or otherwise making software modifications to the system. It includes capabilities for fast frequency hopping using GPIO, as well as low latency loopback bypassing the JESD204 digital interface. All of these DSP features are on silicon to offload any need for these resources within the FPGA. Additionally, ADI now offers a system-level phased array development board which uses 4 of these AD9081 ICs as its backbone to create 16 transmit and 16 receive RF channels, or 32 transmit and 32 receive digital channels. It also enables customers directly by eliminating the need for costly or long development in-house prototyping board spin designs to first verify a phased array system under their desired setup prior to deployment. The Quad MxFE board integrates 4 MxFEs. On the top of the board include the received signals, which include the RF amplifiers, balance, and filtering. On the bottom of the board are all 16 transmit channels, which also include in the front end the RF amplifiers, digital step attenuators for gain control, balance, and filtering. Also on the top is the clocking. It takes a single 500 MHz signal onto the board, which then gets distributed to 4 ADF4371 PLL synthesizers to directly clock the MxFEs. A single 12-volt applied derives all voltages needed for the board. Micromodules are on the bottom of the board to allow for multi-rail system. It also includes digital interfacing, such that the SerDes is over a single FMC Plus connector. And HMC7043 delivers sysrefs and FPGA clocks needed for the platform. Now connected to a calibration board, which is also available, to elegantly loop back signals at various places along the signal chain. This calibration board is controlled via a PMOD interface or dip switch for ease of use to switch between single channel or combined performance testing. The Quad MxFE incorporates direct LS band sampling. It has 300 mils between connectors or 600 mils between channels and produces an X-band lattice spacing so that you can have X-band systems realized with attached up-down converter blocks. In total, it is about 10.2 by 4.5 inches in size. Using the Quad MxFE, the customer is able to apply their own test conditions to this reference design to quickly determine its suitability for a particular multi-channel application. The Quad MxFE supports multiple device clock frequencies. Bill of material swappable filters provide RF operation across multiple Nyquist zones, and external sysref requests allow the user to verify multiple subarray synchronization for applications requiring more than 16 RF channels, but yet which all channels in multiple subarrays still need to be synchronized. The Quad MxFE allows the user to develop larger system-level calibration methods which are sufficient over time and temperature, such as by allowing adjustments of the PLL synthesizer clock phases such that all of the first TX channels on each MxFE are aligned. The development platform demonstrates how multi-chip synchronization is achieved using these MxFE ICs and highlights how this can be scalable across larger arrays. The end result is a quick full system demonstrator for many multi-channel applications. The Quad MxFE development platform comes with documentation detailing the design to help with platform bring-up at the customer facility. This includes online a user guide which describes the platform operation, software downloads containing all of the image files in a single zip file, HDL source for those wishing to synthesize their own design, which includes ADI's own JESD 204B and CIP, MATLAB interfacing via a free add-on, as well as online support via EngineerZone. The platform also includes a GUI interface called IIO Oscilloscope to gain familiarity with the system. This GUI allows the user board control of NCO frequencies, phases, DSAs, SPI writes, reads, as well as temperature, voltage, and current monitoring. It allows for receive captures for all 16 receive RF channels, and these captures include options for time domain, frequency domain, or cross-correlation data analysis. Customers requiring an extra level of control can also develop with the development platform using MATLAB via the free add-on from ADI. MATLAB platform interfacing allows the user full board control to automate test setups under their own use case scenarios. It also allows the user to develop system-level calibration algorithms, as well as demonstrate multi-chip synchronization. The customer is able to integrate their own custom IP into provided HDL and quickly determine the system performance for their use case. As such, it showcases the application-specific features such as fast frequency hopping or low latency loopback capable on MxFE. The MATLAB interfacing can grab simultaneous receive captures for all channels directly into MATLAB for data analysis. In conjunction with the calibration board, the system is completely contained without the need for external lab equipment. The Quad MxFE platform enables customers an out-of-the-box option to develop multi-channel, high-bandwidth system demonstrators for customers seeking novel phased array architectures requiring low size, weight, and power integration. This platform truly realizes the building blocks required to achieve software-defined radars, electronic warfare, or satellite communication systems, but also can be leveraged by the instrumentation and 5G markets. For more information, please visit the Quad MxFE website or go to analog.com and search for aerospace and defense.